In section 8.9, we're going to cover direct and inverse variation. Before we dive into actually solving for this, we need to talk about a prerequisite portion and topic that shows up within this entire chapter, and that is the idea of the constant of variation. The constant of variation is often defined using the variable k. And this helps us determine how the two variables that we are going to be using in our equations, how they vary with one another. It should also be noted that this constant of variation k must be included in all of our variation problems. I'm doing 3 underlines here. Not working. We'll keep just 1, but must be included in all variation problems. And in some instances, most instances really, we actually need to solve for this. We have an outline right below here. I'd like to highlight this as well. If you need to solve for k, you're generally going to be given 2 scenarios. You'll be given some instance where we have the relationship between the 2 variables, and then we have the relationship that we are being asked about. Find x when y is something. Find y when x is something. And we generally need to start filling in blanks to make that happen. More often than not, if we are given a scenario like that, this means that we need to solve for k first, this constant of variation. Once we have that, then we can actually go through and solve the question and the problem that is presented to us. So now that we have that prerequisite knowledge out of the way, we can go into our 2 different types of variation that we have showing up here. So we have direct variation, which is written in this form here, y equals kx. And this is commonly written or typed out as y varies directly as x. There are some slight variations you can and will see with this. We'll go through those here shortly. But our other type of variation that we have is inverse variation. This is written as an equation as y equals k divided by x. This is often written as y varies inversely as x. You can also sometimes see inverse variation written out as an equation as xy equals k. It means the exact same thing as our equation written up here. These are equivalent equations. That's just different ways of writing them out. I've seen many instances where one will be quote-unquote more effective than the other, one will be quote-unquote more accurate than the other, but at the end of the day, these are pretty much the exact same equation, and there's not much difference between them. Now, the instance that I do want to talk about where we can and will see some variation with both of these instances is maybe we have something written using direct variation as the example, where we're told maybe y varies directly as x squared. Maybe there's a squared showing up in there. If that's the case, then we would see an equation written out as y equals kx squared. The part that comes afterwards, that x squared, that's going to get written in there. Maybe we have something using the inverse variation as an example. Maybe we're told y varies inversely as the square root of x. It's not showing up particularly well, but we'll work with it all the same. Now the adjustment here would be to write this out as y equals k divided by the square root of x. So make sure as you are writing these things out for yourself, you're reading what varies with what else. Is it x squared? Is it the square root of x? Is it just x? Maybe it's something raised to a different power. But these small variations do show up in these problems, so be on the lookout for that as you are going through these. Reading and looking for the buzzwords is the giveaway for this entire topic and section that we're covering. So now we have our process listed out here. Again, I'd recommend as you're going through these, taking a moment or pausing the video where it's necessary to write this down for yourself. Because this is what I recommend we do as we go through all these problems. So first and foremost, we're going to write out the formula for the type of variation described in the problem. All we're looking to do with this first step is establish, am I working with direct variation or am I working with inverse variation? That's all I'm looking for. My recommendation is look for the different buzzwords that could go along with that: direct, inverse, variation, direct variation, something varies inversely. All these buzzwords will give away which of these two types that we're going to be working with, but you do need that at the very beginning of the problem. Now, as I mentioned at the very top of this, a lot of instances we are going to actually need to solve for the constant of variation, k. So what that means is we're going to need to do step 2 and substitute the given values in for the variables. This will have to be told to us. It'll be given somewhere in the problem. So we'll sub in what we know for x and y, and then, as we do in step 3, we're going to end up solving for the constant of variation. We're then going to have a resulting equation showing up, similar to one of these that we had here, or something like we had here, except instead of that unknown k, that will be replaced with a number. That number could be a positive, a negative, a fraction, a decimal, but something like that in place of the constant of variation. Once you do this, you're then going to write out the new expression, and now we can solve for anything that we're asked to do afterwards. So again, very often we will see, and we'll go through some examples with this, two scenarios given to us. One scenario where we're asked to solve for one of the equations given the other one, and then a different scenario where we have been given both variables involved in the problem. And we're going to see how those play out in a couple examples down below, but again, this is the process that we are going to be using as we're going through these examples. Example 1 tells us if y varies directly as x and y equals 21 when x equals 8, find the equation that relates x and y. So in this problem, we're asked to just make an equation out of this. Now we again are looking for buzzwords. We're told something varies, and more specifically, something varies directly. In this case, we're told y varies directly as x. That's our giveaway from the very beginning, that we're going to start with our general direct variation equation. So we're starting with y equals kx. We'll figure out the rest later, but we know we're starting with that equation. We are also told y equals 21 when x equals 8. So right there we have been told some information about our variables y and x. We can use that to therefore find our constant of variation k, which is what we are missing. Whenever we're told find the equation that relates x and y, we start off with our general equation. We need to find k, so the only variables left are x and y. So I'm going to plug in what I've been given for 21, or for y I should say, that's going to be 21. I'm going to plug in what I know for x, which is 8, and I'm going to solve for k. So I'm dividing both sides by 8. The 8's cancel. I'm getting 21 over 8 is equal to k. That can't reduce any further, so I'm good to go there. Now I'm bringing everything back together because I am asked to write an equation that relates x and y. So I'm writing this out as y equals 21 over 8 times x. It's very important that when you are doing this, you are answering the question and what it's specifically asking you to do. A lot of people will go and make the incorrect assumption that, oh, I found my k value here, I'm done. But that doesn't answer what the question is specifically asking for. We're told to find the equation that relates x and y. So make sure you are doing that as you're going through these problems. But otherwise, if we do that, we have our answer here for number 1, and we're good to go. For example 2, we are told m varies inversely as n, and m equals 18 when n equals 1/3. Find the equation that relates m and n. Once again, we're trying to figure out some buzzwords that stand out to us. Step 1 in our process is to write the formula of variation that we're using. So again, we're looking for buzzwords. We're told something varies inversely. So that right there is my giveaway. Then I'm going to have the inverse variation problem. We're told specifically that m varies inversely as n. Nothing particularly weird showing up with that, other than compared to our general example, I'm not using y and x, I'm using m and n here. So I'm starting off with the general equation, m equals k over n. So we're good there. And now I've been given some values here for m and n. Step 2 says to substitute those given values in for the variables. So I'm plugging in 18 for m. I'm plugging in 1/3, there we go, for n. And now, step 3, solve for the constant of variation. I want to get the k all by itself. From here, using what I know with fractions, I don't like dividing by fractions, so instead I rewrite this to say I am multiplying by the inverse, or the reciprocal of that fraction, I should say. So this thing gets rewritten as 18 equals 3k. I divide both sides by 3. I'm getting that 6 is equal to k. So excellent. Last thing I need to do, rewrite this as one equation, because that's what I'm being asked for. I no longer need to write in k, I know what that value is. So I get my final answer for number 2 as m equals 6 over n. Examples 3 and 4 are going to have us go through and do the kind of two-part problems. So we're given one scenario and we need to solve for another scenario. So looking at number 3, we're being told if a varies directly as b and a equals 16 when b equals 4, find a when b equals 1/2. So this is going to sound like we have a whole lot going on with this problem. And again, I think it can be overwhelming to try and look at this as a problem we need to solve all at once. I generally think that's where a lot of people struggle with these. So we're going to break this down and do it in smaller controlled parts. We're told a varies directly as b. So let's start with that. That tells me I have direct variation. If I look back to my notes, I'm noticing I don't have y and x as my variables. I have a and b in here. So a mild adjustment to the original equation, and I'm getting a equals k times b. And again, that falls in line with our original starting thing that we have here. Now we are told that we need to find a when b is 1/2. So even if I plug 1/2 in for b here, I still have this constant of variation as an unknown currently, so I could not find an actual a value with this. So instead, what I need to do is use the provided information for me to find that k value. Then I can solve this second scenario for a. So we do some prerequisite work, then we can actually solve this thing. So step 2 is telling us we need to substitute the given values in for the variables. I know a and b in this first scenario, so I'm going to plug those in. I know a is 16 when b is 4. So I can, from here, I can solve for k. I can find what that value is. I'm getting 4 is equal to k. Excellent. Now that I solve for the constant of variation, I can write the new equation that relates, in this case, a and b together, including that new constant of variation. So I'm just going to come up here and rewrite this as a equals 4 times b. Excellent. Now that I have that constant of variation replaced with 4, now I can actually solve for a in the second scenario. So I've been told b is 1/2. I can plug that in for b in this equation. I can go through and solve this thing. I'm going to get a is equal to 2. 4 times 1/2. You could also do that as 4 divided by 2, either one. And we are getting our final answer of a equals 2. Looking at our final example, we're told if h varies inversely as t, and h equals 12 when t equals 1/6, find h when t equals 14. So once again, we have an instance where we are told some information about one scenario and we need to solve for a brand new second scenario. So like we did with example 3, we're going to start with just creating our general equation. We need to find the constant of variation, and then we can answer what the problem is specifically asking for. So looking for buzzwords, we're told h varies inversely as something else. H varies inversely as t specifically. So looking at my general types of variation, inverse variation generally is y equals k over x. We have slightly different variables here, so we're just going to change that up to be h equals k divided by t. Now again, it should be noted here, we always include the constant of variation as a k value. You can technically write it as something else if you would like to, but you do need to note that the constant of variation is somewhere in your original starting equation. So now we're told in one scenario, h is 12 when t equals 1/6. So let's go ahead and plug those values in. We have h of 12, k over, we have t is 1/6. Okay. And now I'm solving this thing for k. Dividing by a fraction is the same as multiplying by the reciprocal, which gives me 6k. I'm dividing both sides by 2. And that gives me 6 is equal, whoops, I'm not dividing by 2, I'm dividing by 6. Looking ahead at my own work here. Getting that all mixed up. There we go, much better. Alright, so now I'm getting a k value or constant value of 2. Alright, so now that I have that, I can rewrite my equation that h is equal to 2 over t. And now I'm being told I need to find h when t is equal to 14. So I'm plugging in what I know, finding h when t is 14. And now, from here, simplifying stuff down, I can't really do a whole lot to simplify this thing, and I'm getting that h is equal to 1 over 7. I can't do anything else from here. So I have my final answer, and I'm good to go. There's nothing wrong with getting a fraction answer at the very end, and sometimes that does happen. Make sure when you're doing this that you are going to leave your final answer as a fully reduced fraction like we did here. But otherwise, we're good to go. So a quick summary of our direct and inverse variation problems can be seen here. Again, I would highly recommend that we take note of our main types of variation that we will be seeing and our process that we have written here. If you follow this process, it doesn't matter what kind of a problem you've been given, whether it be like the 4 examples we went through or we went through any type of story problem. We always have to start with some type of variation, find and solve for that constant of variation, and then rewrite our brand new, completely finished equation out for ourselves. Once we have that, we can solve for anything they ask for afterwards. But it all starts with this main original process. Make sure you are keeping an eye out for those buzzwords. Some of those are listed here, but you'll see other ones listed out in the problems that you'll be working through later. We'll go ahead and scroll us down here. Give you some example problems if you'd like to try some of those. So again, I'd recommend pausing the video here if you need to or would like to go through and try these problems. Otherwise, we're going to scroll on down and find the answers. So there's our answers there. And this concludes everything that we have, and we're going to be working on with direct and inverse variations.